Hi, I'm Priyanka. My team members are Avinash Venkatesh and Kranti Kumar. Our cloud machine learning project is based on a weather prediction at Darwin International Airport, Australia. And this we are doing by using the Azure machine learning. And coming to the introduction part, the main aim of this project is to leverage the Azure cloud machine learning to develop a cloud-based solution for accurately predict daily maximum temperature at Darwin International Airport for the month of Jan 2024. We are getting this data from the following website NVOA, and the Pandas, Arima, and Sarima are the models, algorithm models we are using here, and root mean square error was used to test the model. Next. And this data which we required for the project is recorded of the weather like precipitation and temperature values was taken from the following link which is shown in the screen from the NAO website. When you click on the screen, you can get the following dashboard appearing as shown in the screen. And this data was uploaded into the Azure Machine Learning Studio notebooks. This was pushed into the Python, and here visualization, manipulation, and of the coding was done, and this we are deploying in the Azure. And coming to the coding part, so we are deploying our here in the Azure. So this is the coding part. So here you can see like we are importing the pandas as a PD, and the importing data and indicating the unique column data values. Here it is a coding. This is the code, and we are running it here. And this also we are tabulating the data. So we are getting the data from 1980 to 23 December 2023 December. And here we are checking the completeness or any values are missing from our data. And this is the code, and this is the result. And changing the column names to lowercase, and this is the code, and this is the data. And filling negligible missing values of the temperature, and this is the code. And filling missing values by pattern, and checking index or to ensure incorrect types, and to ensure the data is changed to time to ease the data wrangling. And this is the coding part. And the next part is explained by our team member Avinash.
Yeah, hi Professor. This is Arnash. As of my ID is 2224681, and in this project, my contribution is related to model building. That is, which we are in this project we are going to use. We have built like using the Aramia and Seramia algorithms for identifying the best model parameters, which you are able to see in the screen. That is, we have attached the code snippet in the PPT presentation. And apart from that, in this project, we are going to split the data into testing with the training sections that will be which are going to testing the test and holding. It will be on 50 observation, which is going to rest on the training. That means if you are checking in the screen, we can attach the sample which we have giving the testing scenarios. Now I'm going to explain my part in the coding which I have done in the screen. This is the collected data, which my team member is showing, and my contribution in this was data sorted. We have collected the data from the 1982 December 2023, which you are able to see in the screen, and we have attached the pictorial representation also, like by labeling the date, temperature, etc etc, date and the temperature related. Now, if you see the max plot, this is the pictorial representation of our project. Kranti, can you scroll down? And coming to the, if you see here on the screen, code snippet part, what are the algorithms we have used? That it's going to be displayed like Darwin's Airport, what we have taken. And the next scenario, if you see, these are the collected data which we have taken from 1980 to 2023. And the coding related, we have here used different values like lags, whatever critical situations, whatever, like different data, different types of data sets. if you are able to see that we have implemented what previously I have mentioned, two algorithms like ARIMA and SARIMA. If you scroll, Kranti, can you scroll down? Like figuring what are the we have based on the algorithms we have imported these things, and we have given the scenarios also. Can you scroll down? And these are the simple based on the algorithms we have developed our code with the ARIMA related. And this, can you scroll down? This is the collective data up to 2023 December what we have taken. Um, Next part will be continued by our team member Venkat. Venkat, can you please continue?
Sorry, model evaluation is mine. My name is Kranti. My ID number is 23113383. This model evaluation is nothing but you can see it here. Firstly, we are showcasing the performance of our temperature prediction model. It was established that the average actual daily high temperatures in our test set, where you can see it 93.6 degrees. After that, we assessed our model accuracy using an evaluation measure known as RMC, which is root mean square error. Our RMC value stood at 2.23, implying it is a quite low. Coming to the code part, can see it here. Here can see it here. Here, sorry. Yeah. Prediction test data. You can see it here. Here we compared our model prediction to the recorded temperature of December 2023. You can see it here. And we saw that our model prediction were consistent across the month in sharp contrast to actual recorded temperature, which fluctuated significantly, amplifying the imperfect as it is in our model. Still, you capturing some underlying trends. We can see it here. Yeah, this is the Tmax code for predicting. And coming to that 93.6, you can see that in PPT, it was a Tmax value. Coming to that checking part, here we can indicate how to RMS was calculated. RMS was computed after plotting model predictions against the actual temperature and finding their difference. The RMC value is 2.23. You can see it here, 2.23. Finally, and confirm that the fact that our model is really good at predicting daily maximum temperature. This is the model predicting. The next part is explained by Venkat.
Hi, hi, my name is Venkatesh Palleni. My student ID is X22223673. Now I will going to explain my part of project future daily maximum temperature prediction and as well as conclusion. Kranti, can you scroll down for the PPT? Yeah. Here we can see the since the last day in the data set was 31st December 2023. Dates from the whole month of the January 2024 we are generate. Okay, we can see the code section. Can you show the code section, Gandhi? Yeah, we can see the code section. Indicate the presence of the existing ARIMA model named as a model 2, which has subset of the data set. We can see the first line of the code is ARIMA weather Tmax order 211. Can you scroll up, Gandhi? Can you scroll up? Yeah, that's fine. Yeah. In this line, initiate a new ARIMA model using the daily maximum temperature data from the weather Tmax. The parameter order 211 is defined for the ARIMA model. In this case, to indicate for the log of auto-regressive component, and one indicate for the time series of the stationary, and another one is indicate the log of moving average component. Yeah, model 2 is equal to model 2 fit for the next line of the code. So this line fit for the ARIMA model, the data set, calculate the parameter of the ARIMA model based on the input data from whether Tmax. Next, we print the data uh, in this action to examine the most recent data point within the data set. Okay. Next I will explain the we can see the next section. We are focused on the predicting daily maximum temperature for the upcoming 30 days using the ARIMA model. First, we generate the future dates. So we can see the first line of the code. PD date range is starting from 1st January 2024 and 31st January 2024. Yeah, first we generate the code, and next one we print the future dates, and printing the future dates. Then after marking the predictions, you can see the marking the prediction. The prediction index is future dates. We can assigning the future dates. We can see the output of the prediction future temperature. We can see it. Then next we can use it to create a plot the precise daily maximum temperature. We can see the future daily maximum temperature will be between 94 degrees Fahrenheit to 95 degrees Fahrenheit. We can see the plotting also. This is our output. This is our project. Thank you. Andy, can you stop the recording?